Good morning and welcome to Data Center. In our previous class, we considered different post-hoc tests and non-parametric analysis. And I said we have one more class before we put a close to this and then proceed to machine learning. So we'll be looking at time series. Time series. A time series in Python is commonly used for various tasks such as for forecasting, detecting trends and seasonality, analyzing patterns over time. This in turn helps to make informed decision, not only that data-driven decision based on temporary data. So we're looking at different time series analysis as time parameters. We have the time series, time series for that is for forecasting. Okay, this helps us to predict future values based on historical data, and it is widely used in the financial markets, weather predictions, and demand forecasting. Another one we're looking at is trend time series. A trend in general directions in which something is changing over time. In other words, you can use this type of analysis to identify trends in the data set, which help us to review long-time patterns. For instance, upward movements of stock prices or downward movement. Another one we'll be looking at is seasonality time series. Seasonality refers to patterns that repeat at regular intervals, such as monthly, quarterly, or yearly cycle. For instance, retail sales may spike during the holiday season each year. Then we have anomaly time series. Okay, this type of time series can be used to determine anomalies or outliers, which indicate unusual behavior such as fraud detection, equipment failure, or sudden market movement. We also have decomposing time series. This involves separating the data into trends, seasonal, and residual or we call noise components. This help this is helpful in understanding the different underlying factors in a data set. We also have autocorrelation time series. Autocorrelation time series helps in identifying if past events influences future value or future occurrence. This is often used to check for lag effects in time series data. Then we have classified time series, which classify time series usually use the machine learning techniques for tasks such as categorizing sequences of events, activity recognition, and diagnosing system behaviors. And then we have smoothing time series. This is used to remove noise from time series data and make trends more apparent. So we hope to be able to check some of these analysis as time parameters. All right, so once you root on your system, go to your search, you can use the bash, the anaconda power prompt, and then you type cd, that is change directory. And then if the folder your working folder is on a desktop, then you type cd then space desktop, click on your enter, press your enter key. Then the name of the folder, this time around you type cd space the name of the folder. In my own case, I'm using Python for the name of my working folder or directory as the case may be. Then you type the name of the folder, that is if you're using for instance Python cd space Python, then you click on enter. Then once you have done this, you can then type Jupyter space notebook to on the environment. Once you do that, click on enter, and then the environment will open on your browser. So I have my here. All right, now it's open. So the next thing I'm going to do is to go to new, click on Python 3 IP kernel. All right. Okay, we're still waiting for it to load fully. All right, it's coming up. So we can quickly name this now. Time series analysis. Okay, so I'll rename this. Then we'll start. So the first thing we'll be looking at is forecasting. Let's change this to forecasting time series. Okay, and we'll be using the ARIMA here. The ARIMA model or library that we are going to be using for this purpose. Okay, as I'm using ARIMA. We can start doing our importation now. We import pandas as PD. Then we'll be using this ARIMA model. That is from the start model.tsa.arima.model. We are importing ARIMA. Then we're using this matplotlib for charts. All right, so I guess we can read our file in now. Is equals to data set stock prices pd idf is equals to pd dot read csv. Okay, then stock uh, prices, right? Dot csv file. Okay. Okay, so before we proceed, let's see df dot add. Let's load this and see. Choose for a response. All right, we have this. We have this. Okay, so let's check if we have empty sets. So, okay. So when we check for empty row, we have under open, we have 11, I we have 8, though we have this volume, nothing under volume. Okay, so since we'll be using our volume and the dates for this purpose, we may not need to remove it. I'll just keep it that way. I want to use volume and the date. We want to see at what date do we have highest volume, at what date do we have the lowest volume in stock exchange. Okay, that is what we want to achieve by this. All right, so another thing we also want to check is the data type. Okay, so the date is object, the volume is int, So we should be able to work with this. All right. So I can copy this now. Copy this now and paste. Now we editing some things here. Okay, I have to pass the column I want to use here. Okay, into this. All right, so let's go. I want to do this. In this column, we have dates. Then we have to pass dates. As dates is equals to true. Next thing we are going to do is to train our model. Okay, here we say we are using volume. Next thing is to specify the order to which we want this order. Now we have ARIMA. Harry, AR is one order, I is another order, MA is another order. Okay, so I'm going to use 510 for my order. 510. Then let's close this. So let's add our comment. AR is equals to 5. I is equals to 1. MA is equals to 0. So that is the order that I'll be using for this model. The next thing is to fit our model. Model fits is equals to model dot fit. Okay. Let's then forecast. So we want to forecast this model for the next 10 days. Okay. You can change it for maybe you can put 20, 30 respectively. For this time around, we are forecasting this model for 10 days. Then the next thing we are doing is to plot. Okay. So we want to plot, we have volume. Okay. Nice. Dot plot label. Okay. Then the next one again forecasts dot plot label. Then we have plt dot legend. We have plt dot show. Let's run this and see. Here's our results. Order not defined. Let's look at it. There's a mistake somewhere. Let's look at it. There's a mistake somewhere. Order. Okay. I'll just put equal to, this is the order, is equals to this. Let's define it. Okay, let's see. Let's see. Okay, so looking at this error, it said a date index has been provided, but it has no associated frequency, and so will be ignored. So what we're going to do is we are going to set that date, and then we are going to set a frequency for it. So I'm going to show you how to do that. So we have to move and correct this. Okay, we have df dates, right? This view, okay, let's use the square bracket. We have dates, Okay, we have this other one. We use our pandas, pd. So date time df. Yes. Then we set the index to date. Okay, so we have this. Sorry, this is pd dot to date time. Okay, so the next thing we are going to do is to set a frequency. Let's come here, set a frequency. Df is equals to s. So we are using here. Okay, okay, so it's not set, it's supposed to be df as frequency. Why? Okay, 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 okay. So let's try this again and see. Okay, there's an error somewhere. Df as frequency. Convert time series to specify frequency. Okay, let's correct this. Okay, so looking at this code, let's quickly debug it. All right, let's debug it. Look at it. Cannot reindex from a duplicate axis. It means there is duplicate in our data set. So what we do is we remove the duplicates, okay, and then keep the first. So to do that, so we'll put the code before this. So we are saying the index, that is df dot index dot duplicated, keep the first. You understand? So it will remove the other ones. Let's go and let's check and see. Okay. It said maximum likely optimized failed. This is for, I guess you have 20 years there. This is 2015. The data is up 2015 plus 5, 2020 plus under 5, 2025 plus under 5. So 20 years is 2035. So and the volume is at our y-axis. This is 0.7, 0.8, 0.9. They have 1.1 here. Then the our forecasting has been constant here, so the data is not look, and that is why we're having this 2p observation to estimate starting parameters. So let's change this to day. D means day. Okay, Waiting for the result. Oh, well, we have the results. Okay, you can see for 2014, that this is moving by 1 to 2015, 2016, 2018. Now, since we're moving by day, if we look at the volume here, it's at 2. This is 0.4. 2015, one of the days here, we have this. Then it has not been higher, it has been low, 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 except even this, our forecast is also low. So let's change this to months. That is the frequency. Okay, waiting for the results. All right, we have our results now. This is months, so for the next 20 months. So if you look at it, it has been scattered. 2014, look at it. Look at it. 2015, we have that same high point here. That's in 2015. It came down. Then from 2018, if you are using this same data to forecast, you notice that the volume we are going to have for 2018, 2019, and upward for now for 20 months will be very small. Let me increase it so that since we're in 2024, I will change this to like uh, let's assume 60 months. Right, we have our results. So 2022 has been constant. I want it to get to 20. Let's change this to 100. Let's see. I can get 2024. Watching for our results. Yes, we have our result now. So it's up to 2025 and beyond. So you see, if I'm using this data to, it means the volume here is very low. Can you see it? It has been constant from 2018 here down even up to 2025. So this is how forecasting it helps you to predict. It helps you to forecast based on historical data. So if you're using for data forecast, you want to know if it's going to rain, the same approach. All right, so we have the data set. The data contains the opening, the close, the low, the high, and then the volumes generated. So we are using the volume alongside with the date. So now what we did was to convert the date to date time. All right, and then set an index with it, and then we then have to remove the duplicates. It contains duplicated date, so we have to remove the duplicated date, and then we now set frequencies for it. That is, we use Y for year, uh, M for month, and then D for day. So let me quickly add something here. Y for year, M for months, and D for days. All right. Then before we now use this our model ARIMA model. All right. So I want you to practice this data set stock uh, prices. I got it from Kaggle. You can search for it on Kaggle. You download, and then you can practice. Then you will make sure you follow the code accordingly. Okay. So we're going to go to trend detection. Before we do that, I'm thinking of uh, doing something here. Okay, let's do this. Print forecast. Let's see. Okay, so this is it. So this is the volume for the next 100 days. All right. So let's change this to trend detection. We want to study the trend, the pattern. Okay, that's what we want to do here under this analysis. Okay, so I'm not going to import another library again since I've done that here. I have matplotlib, so I have a PD, so I'll just leave that. So we have trend detection. So let's do this load data sets. Okay. So I'm loading this now. We have there's this data set I downloaded from Cargo as well. So we are loading this into it, and we are this time around we're using index column, the month, and then we'll pass the date into it. Okay, to be truth. So the data set basically, let's do this dot add contains it contains the months and the sales. Okay, let's use a tail. See what we have in the tail. 1968. So it's just as this is just like data as well, but from the data set, what they use was months, and so because you can see we have 1968 and a month respectively. Okay, so since we have this, the next thing to do is to start plotting. Okay, to study the pattern of sales across these years, across these dates. Is that okay? Okay, so let's go ahead. Let's do this. Let's do this. EF, right? Sales. It's capital letter X. Sales dot plots. Plots. Okay. Okay. So plots. Can I use this now? Label. I can use sales. Let's just use that, or yearly sales as a guess maybe. Yearly sales. The next thing we want to do is to use a moving average along this. So use a moving average as it will roll across this. That is the mean dot plot labeled 12 months moving average. That is a year, right? Line width that is 2. Then we have plt dot legend, plt dot show. Let's run this and see. Wow, so you can see this is like how many? 1960, 1961, 1962, 1963, 1964, 1965, 1966, 67, 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4. 1, 2, 3, 4, 5, 6, 7, 8, 9. Nice, across 9. Okay, let's see this. Let's change this to 12 and see what we're going to have. Okay, let's see. 1, 2, 3, 4, 5, 6, 7, 8, 9. So it means what we have here is this top here is just uh we are just for 9. Okay, 12. Okay, so make it 9. The width of this line is just 2, and then okay. So you can see the trend how it is not constant, it is zigzag. It is zigzag. At this point at 1960 it roses, then came down in 1961, then between 1961 and 1962, and the middle of it, it rose like that, you can see. And then in 1968 here it moved to the peak, that is around 19 towards the end of 1960, or the middle of it, it rose to the peak. So this is detection of pattern, okay, line trends. Okay, so it helps us to detect. You can see the consider the pattern of markets, and you can now predict, okay, this is how it's moving. So if I'm to enter market, I'm likely to do this if I follow this. All right, so that is that about forecasting. We've done just two today. That is forecasting using time series, and then pattern detection as trend detection. All right, thank you for listening. If you have not subscribed, time on the same venue, on the same uh same time.